Let's go ahead and take a look at number 7. In this particular problem, we read in a particular city, 97 and 2.9 million people have been struck by lightning. What is the experimental probability of being struck by lightning in this city? So what we have is the following. We want to divide how many people have been struck by lightning, which is 97 divided by 2.9 million people. Now, a million means that it's 10 to the power 6, 10 times itself 6 times. So a 1 followed by 6 zeros, this many zeros over here. Now, if we have 2.9 millions, then it's 2.9 times 10 to the 6. So it's 2.9 times, a 1 followed by 6 zeros. But notice you have already a decimal right here. So what you have a 2.9 times a million. And every time you time by 10, you're going to move your decimal to the right to make the number bigger by 1 spot. So if you have 2.9 times 10 to the 6, you need to move your decimal 6 places. So 1, 2, 3, 4, 5, 6. So here's my decimal right here. And what you have to do is put some zeros in all of those little spots. It looks like an egg crate. When you buy eggs at the store, you have a little zero in each of those spots, over here, like a little egg in each of them. So what do we have here? We get the following. We need to put our commas to understand better what's going on. So it is 2,900,000 is really what we're talking about. So divide 97 by this population of 2,900,000. And let's see what the calculator says. And we want to write that as a percentage, but it's going to be rounded to 4 decimal places as needed. So let's make sure we can do that. So we have 97 divided by what we were mentioning over here. It's written as e to the negative 5 power. This is engineering notation, like 10 to the negative 5 is what is timing that number. So if you wanted to get the answer for that, let's see, you would have to move the decimal 5 places to the left this time, and then write it as a percentage. Okay, so let's go ahead and check out. So you may think that you need 4 decimal places like that, but remember, you have to time this number by 10 to the negative 5, which is really dividing it by 10 to the positive 5 power. So it's dividing it by 100,000. So it's going to make that number very tiny. So all you have to think about is the following. Start with the number they gave you and move the decimal place 5 places. So 1, 2, 3, 4, 5. So here's my decimal place. And I need to put some zeros to hold the spot. And I can put a 0 in the front or not, that's up to me. So what happens is that you have 0.000033448. So if you wanted to write that as a percent, you would move your decimal 2 places to the right, and your decimal would be here. So you would be talking about 0.00333448. But think about it. If you write it as a percent, okay, you already have taken care of moving the decimal, but they want you to only use, what did they say, 4 decimal places. Okay, so what we need, use a decimal with 4 decimal places. So what we'll have to do is the following. You just take this much of the number. So you really didn't need those, but it's with all the moving around of the decimal, it's a little hard to predict. So just go ahead and write that what we have, the experimental probability of not being, sorry, I'm filling out the wrong thing here. Okay. They still want me to do 4 decimal places, so I'm okay with that. But I just want to put the answer here, so 0.0033%. Okay, so that's what we have for an answer for this particular problem. So a lot of moving around of the decimal. So for the other question, you may think, oh, let's do it the same way, but be careful. They tell you in a particular city, 72 in 2.6 million people have been struck by lightning. What is the experimental probability of, and be careful, not being struck by lightning? So we'll have to be a little bit more careful with this one. So the first thing I'll do is the following. I'll rewrite this big number here of 2.6 million people, you know, the way that we can relate to it more easily. So it's 2,600,000 people. That's how many we have altogether. Now let's keep in mind that 72 of those people have been struck by lightning. Now they don't want to know the percentage of people struck by lightning, but the percentage of people who were not struck by lightning. So just visualize it this way. You have this many people all together. This many people. Now you have 72 of them who happen to be struck by lightning, and the rest are what they want, not struck by lightning. Now, how can we find how many that is? We just take the total and subtract from that 72. So when I did that, I did get how many were not struck. And in this situation, this is how many were not struck. 2,599,928 of them were not struck. So when they ask you the probability of not being struck, you want to use this red number we just found of how many were not struck and divide that by the total number in the population. So the answer they're looking for comes from taking 2,599,928 and dividing that number by 2,600,000. And let's see how much we get. And I'll also show you that indeed we get this number when we take away 72 from the whole population. So now if you have the 2.6 million people minus the 72, indeed we get the number that I wrote in the numerator of that quotient we need to evaluate. So if I divide now 2,599,928 people who were not struck by lightning, divide that by how many we had, we'll find the percentage that we're looking for. And we get, oh, this time they wrote it nicely in the way that we can relate to it more easily. So let me write what we want. We want 4 decimal places, but as when it's written as a percentage. Okay, so let's go ahead and make sure that we take enough digits. I will take it up to the number 2, which we see in the decimal number. Let me write that over. So if you take a look and you want to focus on the number 2, whether you leave it as a 2 or bump it up to a 3, since it's to its right you have a number 4 or lower, you're going to leave it as a 2, and that's what we get as decimal number. Let's now write that as a percent by moving the decimal 2 places to the right, and let's see what we get. Okay, so we will get that our answer is 99.9972%. So let's just write this number in the spot, so 99.9972%. That's our answer, the experimental probability of not being struck by lightning in the city. So now in problem 9, we're doing a little bit of comparison. We have in city A, 4,274 out of 5,801 residents have reliable high-speed internet access. So that's city A. So let me write all of that in blue. Now we have another city, which is in city B, 15,043 out of 21,952 residents have reliable high-speed internet access. In which town are the residents more likely to have reliable high-speed internet access? So in this particular question, as you see, we need to compare the two cities. They want to know the experimental probability of having reliable high-speed internet access first in city A, then in city B, and then they want to decide which one, in which town are residents more likely to have reliable high-speed internet access. So basically compare city A to city B and decide which one is the best, for reliable high-speed internet access when we look at the percentage. So first thing we need to do is find that percentage. Again, we always proceed this way. We're going to divide how many over here have reliable access internet divided by the total. So this percentage comes from this quotient, 4,274 divided by 5,801, and that will give me my blue percentage, which I'll evaluate in a moment. Now for the red percentage, which I'll place in this little box here, I will take the numbers 15,043, divide that by 21,952, written as a percent. So I'll just type both of those in the calculator and come right back. So let's go ahead and see what we're going to do. So for the first one, since we want to write that rounded to the nearest tenth, okay, so we'll take 3 decimal places. So we're talking for this one, because it's 0.7367. So when you look at the 6, bump it up. So we're talking about 0.737. Move the decimal place, 73.7%. For the other one, we get that it is 0.685 over here. And there's a 2 here, so just say that it's 0.685. Move the decimal, 68.5%. So CTA, as you can see, has a 73.7%. CTB has a 68.5%. So which one has the best internet, the most reliable one, the one with the highest, percentage? And we're going to go with CTA for the next question. In which town are the residents more likely to have reliable high-speed internet? Where we had the highest percentage over here of residents who had such reliable high-speed internet. So that's this one.